and today we're going to talk about heat exchangers and its use for the generation of electricity and power. First of all, let's settle this conception of thermoelectric plant. So it is a place where the power, the heat energy is turned into electric power, and its function bases in the use of a turbine. So the first step is the water is heated, so the whole water turns into steam. That steam generates a spinning of the turbine, and that turbine is related to electrical generator, so it generates electric power. The theoretical function of this process is based on the Rankine cycle, so let's take a look.
And the video is going to be at the end of the season if we have time.
As my partner said, Rankine cycle is a diagram of the Rankine cycle, and I'm going to talk about it very quick. It is based on 4 components: a condenser, a pump, a boiler, and a turbine that is in that makes the work. So, as I said, there are 4 components: the pump, the boiler, the turbine, and the condenser. So, the first step is the process 1-2, and when there is an increase in pressure due to the pump that is here, it is just for making the fluid go through the boiler. The process 2-3 consists in a heat transfer here in the boiler of the fluid. And the process 3-4 consists in an expansion of the steam in a turbine that goes to an electric generator and makes electricity. Part of the steam is condensed in the condenser that we are going to talk about later, and it begins again the cycle. Talking about the efficiency, we know that the efficiency of the cycle is based on the power of the turbine, the power of the pump, and the heat that enters. So we can assume that the power of the turbine is too much greater than the power of the pump. And we can assume that the efficiency of the cycle is the power that we make in the turbine divided by the heat that enters. And there are some ways of improving the efficiency of this cycle. One of these is increase the heat of flow transfer on the fluid in the steam generator. We are going to talk about it later. And decrease the flow of heat transfer rejected from the condenser. Decrease the pressure in the condenser, and reduce the amount of heat in the boiler. There are processes of reboiling and regeneration that my friend is going to talk about.
So we already talked about a general arrangement of this process, but there are a couple of variations that are made in order to increase the amount of efficiency. So reboiling. We have now 2 turbines, the one that works in low pressure steam and the other in high pressure steam. So here goes the vapor. Its pressure is lowered by the first turbine. There he goes. It's reheated in the boiler. So and the temperature and also the pressure increase and re-enters to another turbine. And normally it's used just 2 turbines, because if we use 3 or more, the balance between the work that we obtained and the heat that we implant to the flow, it's not real great. So it's normally used just 2 turbines. So, regeneration. Here, we also have 1 turbine, but this time the flow is divided. And one of this part of this flow is used to preheat the feed that goes to the boiler. There are 2 types of boiler used in this arrangement. So, here we have open boiler. So part of the flow goes right over here, and in this boiler occur a mixture. So here we have a liquid and here we have a vapor. And the idea of this is that the mixing of those flows generates a saturated liquid. And it's important to know that both of these flows need to work at the same pressure in order to preserve the quality of this boiler. And then we have a closed boiler. So now the flows are not longer in contact. So here we have the vapor. The vapor and the liquid are interacting in a shell and tube heat exchanger. So the vapor goes through the shell and the feed liquid goes through the tubes. Because we need to reunite at some point those flows, there are 2 different variations, again on closed boiler. So here we have the vapor that goes, as I already said, in the shell. And in this first variation goes in a pump and reunites to the feed alimentation, and later just to go through the boiler. But now here we have another variation in where the steam shell goes through a valve and is submitted to a prior projector in a lower pressure zone. Now let's talk about the boiler. One of the main important parts of this process, basically because it heats the water that moves the turbine. So in this process we use watertight boilers. So the tubes goes through the water goes through the tubes, and the heat occurs in the shell.
Okay, in this point is very important and understand the function of economizer and heaters. The economizer and heaters recover the energy of the fumes before being evacuated to atmosphere and are necessary to obtain high efficiency in the boiler. The heaters perform the preheater to combustion air, which improve the combustion many fuels and the combustion of pulverized fuel. This graph is very important because this arrange is very important because it's normally used in the HS 19-degree rectangular layer in order to reduce the possibility of erosion caused by ash or steam. In this graph show like forever 22 degrees Celsius that of small temperature reduction, the boiler increases its efficiency in 1%. Air heaters. The purpose of this heat exchanger is to improve the combustion air in the boiler by joining the combustion gases and inlet the combustion air. To our steel heaters, the thermal energy in this transfer from the fluids that circulate inside the tubes to the air circulate other side the tubes. To large cast iron, this air heater is using in the petrochemical industry, very little in the thermal plants, and are used because the high resistant to erosions. Heat metal heater. This air heater consists in the sheet of metal batteries in parallel and transfer heat in cross flow from the fumes that flow on one side of the sheet to air the floor on the other side. Heater with isothermal tubes. The heat absorbing for the hot fumes evaporate the fluid that moves toward the area of combustion air. When working, fluid releases its heat, is condensed, and return the B gravity toward the lower evaporation. Regenerative air heaters. This unit consists of the thermoelectrical plants packet of assembled elements are used. Very dense of a covered steel sheet that use rotation as a produce to immerse the medium in the purpose flows.
One of the most important things of this cycle is the condenser, because we are studying the heat exchangers in power plants. So we are going to talk about it.
Let's take a brief look to the purpose of this equipment. So, basically, what we need in a condenser is to have a huge gap between pressure, high pressure that comes off the turbine, and low pressure due to the condensation, and basically in proper vacuum. And so this proper vacuum increases, this means more efficient and lower flows and a more quick regeneration of the cycle.
One of the most important things that makes the condenser is a pressure drop. In the condenser, the pressure is lowered, so that makes that the enthalpy drop of the steam in the turbine that is up here will increase. So that will make that the power is increased. This will help to make more work, and if we make more work, we have more electrical output.
As I already said before, the pressure drop intervenes in these three facts. Increased turbine output, basically, because I already said it, there's a huge gap between the pressure. The turbine speed is faster, so more power is generated. Increased plant efficiency due again to the move of the turbine, and reduced steam flow.
There are other functions of the condenser. They are not such as important as the pressure drop and condensing the steam, but one of them is removing dissolved non-condensable gases from the condensate, and the other is serving as drain receptance, receiving vapor and condensate from other heat exchangers of the plant.
We talk about a lot of its function and other characteristics, but let's talk about, in fact, the application in these places. So, the condenser used in thermoelectrical plants is a shell-end tube heat exchanger where the steam goes through the shell, is condensed as we see right over here, and the cooling water goes through the tubes. And
the tube materials of the condenser, normally they are copper-based alloy, stainless steel, titanium, but is such as expensive, and carbon steel. The most used are copper-based alloy and stainless steel because of its characteristics and they reduce the corrosion.
lastly but not least, let's talk about the tube cleaning. So, in this kind of exchangers, we have macrofueling is, let's say it in simple words, the common accumulation and the common fueling, and the macrofueling that it's basically biofilms. And we have two different types of cleaning, online and offline methods. Online, it's we can clean the equipment without stopping its function or opening it and disabling. And offline, it's precisely that. I have to open it, I have to tear apart each one of its parts and clean the components.
And so as a resume, we in power plants we have an enter fluid that goes through a pump. This pump goes to a boiler that with the help of heat transfer make it the liquid to go to steam. Then that steam goes to the turbine, and in the turbine we make work. This work goes to a electric generator, and it makes electricity, and it comes again to the condenser. The condenser condensates the steam and goes again through the cycle. And we have here a video to show you how it works, but give us a second.
¿Cuál es el título?
plant. But as you may said, where's the condenser? Yes, in this video they don't talk about the condenser. But as we see, this is the basic arrangement of a thermoelectrical plant. For example, as my partner said, the economizers and the air heaters goes related to the boiler. So it will be right over here, and the lack of the condenser in the video.
Thank you.